Are you excited for another very easy lesson? Well, let's take a look. We're working on 14.2. Here's your essential question. How can you prove and use theorems about angles formed by transversals that intersect parallel lines? I already told you everything about this before today in class, but let me just go ahead and summarize, okay? And it's all here, okay? And we talked about this. What is a corresponding angle? This one and this one. So they're both on top of the parallel lines. Just so you know, these are parallel lines, that one and that one. Okay, and then so you know, this is a transversal. Okay, so the line that cuts across the two parallel lines, that's a transversal. Okay, so these two blue angles, let me just go ahead and change the color actually. The two red angles, these are called corresponding angles. And we call them corresponding angles because look, they're on the same side of the transversal and they're both on top of the two parallel lines, okay? So then it's the same thing. What are you going to be calling this angle and that angle? They are also corresponding angles because they're both on the left-hand side of the transversal and they're both below parallel lines, okay? So same thing with these two angles, this one and this one, the green angles. They're also corresponding angles because they're both on the left-hand side of the transversal and both on top of the parallel line. And I talked about how corresponding angles, they measure the same, okay? They measure the same. What about same side interior angles? We also talked about that. Again, parallel line, transversal, same side interior angles. They're both on the inside of the parallel lines and then they're on the same side of the transversal. So that is a same side interior angle. And so it will be the same thing. These two black angles will be the same side interior angles. And what did I say? They are supplementary, which means when you add the two green angles together or add the two black angles together, they end up to be 180 degrees, okay? Alternate interior angles. I'm gonna erase all of this. Alternate interior angles, again, two parallel lines, one transversal. So that would be an angle that's like this. They're on the inside of the parallel lines, but they're on the alternate sides, okay? Alternate sides of the transversal. Both on the inside, but on the alternate side of the transversal. So these would be alternate interior angles, okay? And what did I say about them again? They measure the same. So the green and the green would be the same. The orange and the orange would be the same. Okay? That's all you need. And this is a repetition. So all these postulates, they're just telling you what I already told you. Same side interior angles, I said they're supplementary. They add up to be 180 degrees, okay? So then I want you to do all of this, and then same thing, alternate interior angles theorem. What did I say? They are the same. They measure the same, right? But then what I really want you to work on is this one right here. So it's a really easy lesson. You just have to take really good notes. Okay, this is what I want you to work. It says work on. It says prove the alternate interior angles theorem, and I told you there's many different ways to prove it, from A to Z. But you know, on your test, it's going to look like this. The statements will be given to you, and you just have to find the reasons. And this is really great because what do you have to do? You see all these options here, all of these. Well, you're just going to pick one of them and put them here. For example, line P is parallel to line Q. What is that? Is given. And I already told you that we always start with the given anyway, right? So I want you to go ahead and work on this, okay? And I don't want to give you the answer because then you won't be using your brain. I want you to work on this in class on the boards. So this is how I'm going to know if you watch my video or not. I'm gonna see how many people go to the board to actually work on this question. So make sure you have this page open, which is the second link in your Google Classroom, and just work on this so I could come and check on your answer, all of that, okay? There you go. And then over here, this is again what I just explained to you earlier. Corresponding angles, I told you where they are, and they measure the same. Okay? So same thing. What I want you to do now, here. Now this is the one that I want you to think about. You have to find each value and explain how to find the values using postulates, theorems, and algebraic reasoning. Okay, but look, in the diagrams, the roads A and B, these two are parallel, and so I'm guessing this is the transversal. So you gotta explain how to find the measure of angle VTU. So here's VTU. In other words, VTU. There you go. So you gotta find the measure of that angle, 2x minus 22. So then let's see, if you were to draw all of this like that, what kind of relationship do you have? So you can see by the corresponding angles theorem and blah, blah, blah. So I want you to take a look at this, but long story short, this angle and that angle are alternate exterior angles, and they're supposed to measure the same. Okay, so you're just going to say x plus 40 is equal to 2x minus 22. Find out what x is equal to, and then plug it back in here to get the answer, 102 degrees. Okay, and so we're gonna work on this. So in the classroom, I want you to be stuck to the boards because I want you to work on this question right here. Okay, so far I have asked you to do 2 questions in the classroom on the boards, okay, with your friends, and when you get stuck, I'll come and help you. Then of course now you gotta work on this homework question over here and that'll be it for today's lesson. Happy learning. Goodbye.